Hello and welcome back. So today is actually a user request day. Someone emailed me a request. They had a question, and I often get, well, not often, every once in a while, every couple months or so, I'll get random questions from people who ask me stuff, and I always try to answer if I can. And this question, after thinking about it, at first I didn't think it would be enough material to actually make any kind of useful video out of it. But actually, after thinking about it, I thought this actually might make a great video. Basically, well, I'll show you the email. I'll hide his identity. But one of the guys said, "I've watched," and actually this may not be a Patreon person. I respond to anyone who asks me questions. Obviously, I will give priority to Patreon people, but I always try to help people out. If you are a Patreon supporter and you have a question, please let me know what your, if you email me what your Patreon username is, so I, can appropriately bump your priority, because I got stuff going on all the time. I'm very busy, but I always try to, regardless of your Patreon or not, I try to respond. But if you're a Patreon person, I will certainly try to respond with, go out of my way if I can to help you out. Anyway, I watched some of your videos on YouTube, very cool stuff. I was wondering if you could help me out on something. Basically, he has a first generation Arcade1Up Pacman cabinet. He wants to learn the patterns, but it's tough because, every time you restart, you start back out at level 1. And so he realizes that in the Arcade1Up cabinet, its MAME, and at least for Pac-Man, you can actually go ahead and also modify the games that are in there, and the menu selection. I don't think I ever did a video on that, but you can. And he apparently knows how to do it. And so he wants to make just different ROM sets with slight versions, where it starts at different version. This ROM starts level 1. This one starts level 2, level 3. Very simple, and that's why I thought it might be too. There might not be enough in there to make a video, but after looking at it a bit, I realized that there's quite a bit of good stuff we're going to have in here. So we're going to be able to look at the main debugger. We're going to change registers. We're going to set watch points. We may have to get into a GHIDRA. We'll see. But one of the nice things this gentleman did is he already did some work. He did his little research on his own, and I always appreciate that. If you're going to email me, at least show me that you try to show me that you tried something on your own and what your ideas are. And I will certainly try to help you, and that will help me, actually help you. So anyway, he realizes, he has narrowed it down to a little RE, that at line, RE is reverse engineering, 690, that when you start the game, that it sets this this memory address 4E13 to 0. And his idea is to just change it from 0 to some other hard-coded number, like 1 or 2 or 3, whatever. And each game would have a different number. And so he had a couple problems. He wasn't sure how to go about doing that. One of the problems he had is that when he wants to change the values, the length of the instruction might actually change, which is actually going to crash. And he's tried this, and it crashed the whole program. So I'm going to help him figure out in the video. Hopefully, we'll help figure out how to actually change this value, and some other things. So anyway, let's get through it. First of all, let's actually validate what he has already sent me and see if it makes sense and it works. So MAME 64 debug Pac-Man. Okay, and so we're going to do a little dynamic analysis here using the MAME debugger. I'm going to open up a new memory window. 0x4E13. That's the memory address we want to watch right here. Okay, that's what the board. That's the memory address he thinks the level counter is at. All right. So now we got a breakpoint at the address that he has specified, 690. So we do BP 0x690, and let's go ahead and start this up and see what happens. Okay, so notice that when we started this, and I'm going to just reset this real quick. I'm going to reset with soft reset, which is F3. Okay. What's this stuff going on? You know, this looks like random junk on the screen, but at the same time, it doesn't look random at all. It looks like it has structure. Any of you guys post want to take your guess on why you keep why when you ever start you see these weird patterns of seemingly random but not at all random stuff. And I might have already answered that in another video, but you know, it's a good, whenever you see something and you like, I always wondered, before I knew what was going on, why did the game start up like that? Ask yourself and figure that out. So that's my question to you guys is, why is that happening? And if someone answers it, maybe I don't know, just if you want, try to figure it out and answer it. But anyway, let's get back to the video, the content at hand. So yeah, 690. He says when I put in a quarter, it will do this instruction. So we'll put in a quarter and hit start. He says it will stop. And oop, I never hit. Let's start that again. I never actually hit the. I never set the breakpoint. So let's restart that. Now we have a breakpoint. All right. So now we have a breakpoint set. So when it gets to that line, it's going to stop. And there it goes. I put a quarter and hit start. And this is exactly what he said in his email. He says that you get this instruction, load register A to when you see this context here or the syntax, this in Z80 assembly is the value of, the address stored here, 4E13. So in that memory address, it's going to store whatever A is once this instruction runs. So A is 00. How can we change A? Let's say we want to set it to level 5. Well, that's easy. Type in the once you're stopped, once you're once your breakpoint is hit, which it is, you hit the value of the register. A equals whatever we want. So let's do 5. Yeah, let's do 7. No, let's do 7. Whatever. Okay. And so now you can see the value of the register A7. We want to now, I want to make sure that, that actually does get to this memory address, which it will, because that's exactly what the instruction is. So we're going to hit, we're going to tell it to go through one instruction, which is called step into, F11. Okay. So we'll hit F11. And you can see here, it went down one instruction. And the value of this address is 7. Okay, so let's continue on. Oops, F5. Oh, what am I doing? F5. All right, let's try it again. Oh, I didn't hit F. There we go. So now we see we have, oh, what happened there? We had, it looked like we had level 7. We had set, we had all those, actually level 8, because 0 is level 1. We had all those fruits down there, but then they disappeared. So that's interesting, right? That's really interesting. Why did that happen? I don't know. Why did that happen? And this video is a little unstructured because I'm basically going about it, trying to figure it out right now with you. So that's interesting. Why did that happen? And you can see here, this memory address is no longer 7. So something must have written to 7 after it's set, after we made that change. It looks like something's writing to that address again. So let's figure out what's going on here. Let's now use a watch point. So we had the breakpoint, and we're still going to do a breakpoint because we want to modify that. But then we want to see what writes to it. You know what? Before we do that, though, let's actually alter that code. Let's alter this code so rather than writing the value of So every time we start, we don't have the breakpoint. Let's and set the register A. Let's actually modify the ROM so that it no longer sets the A to 0. And let's see how it actually did that. Okay, let's see how it actually did that. So we're gonna just once again reset it, and we're gonna look at a few instructions ahead of it. So hit F. We hit put a quarter in, break. And he did mention in the email that the instruction ahead before this, XOR A, sets A to 0. And he's 100% correct. XOR A, you might say that's not setting A to 0, but it actually is. Anytime you XOR a value with itself, it's always 0. It's like if when you were in middle school or high school, they taught you about or maybe even in elementary school, it's been so long I don't remember. You remember the identity function in multiplication when you multiply a number by some number and it gives you back itself. In this case 1. Anytime you multiply 1 by itself, it gives you 1. Anytime you multiply 0 by itself, it gives you, anytime you multiply a number by 0, it gives you 0. No matter what the number is, something times 0 is 0. Something times 1 is itself. Well, XOR is like that. XOR anything by itself, it's always 0. And that's actually a shortcut you'll see programmers use who write assembly code, which is almost 0 people nowadays. But because it's a very short instruction. For example, on x86 or whatever, the instruction to load 0 into a register actually might be many bytes. It might be like 5 or 6 bytes. I don't even know. I don't remember. But the instruction to XOR something might be 1 or 2 bytes. XOR a number by itself. So I think it's actually 1 byte in x86 assembly to XOR a register by itself. I think maybe not. I don't know. But it's much shorter than actually loading the value of 0 into something. Do you care? Probably not. Computers, 4 bytes or 5 bytes isn't going to matter to a computer. But especially in these old days, when every byte counted, that was a big difference. So anyway, XOR A by itself, and by default XOR, it operates on A. So XOR A by itself, that's a shorthand for set 0 to A. I'm sorry, set A to 0. All right, so we want to change this code now so it doesn't actually write 0 into there. It writes, let's say the number 7 again. We'll do 7 into there. So how could we make that code run? Well, we have to do a couple things. We have to actually get the Pac-Man ROM, load it in here, alter MAME to run from that, and then we have to modify the instruction to figure it out. Okay. So let's do that. First thing we're going to do is we're going to download the Pac-Man ROMs, and we're going to unpack them and have MAME run on those instead. So let's do that. I'm not going to tell you where I get the ROMs from because I'm not. Google it, you'll figure it out. I'm going to pause this and download the ROM. Okay. So I downloaded the ROM. We're going to extract it here and delete it. And I'm going to go in there. And I do have to figure out what the load order is. That instruction 0690, that would be within the first 16K bits. I'm just gonna actually guess. No, I'll do it the right way. We'll pull up the main. We'll pull up the MAME information for the game. www.mame.org. I always forget what the total path is, so I just click on source, MAME, drivers, and I think it's packman.cpp. Not, it's Galaga.cpp. It is Pac-Man. All right. So we'll go down to Pac-Man at the end here. Figure out the. Oops. What happened there? The ROM order. Wow. Let's do a ROM. No, that's an easier way to do this. That's one way to do it, but you know what? There's an easier way to do it. I'm just looking for the ROM order. I'm not looking for the memory layout. So let's close that off. Let's do MAME 64 list XML minus list XML Pac-Man. Write it to packman.text. Write packman.text. Pops up and it's going to give us the ROM load order down here. It is Pac-Man 6E. Where's the offset? Offset 0 to 1000. Okay, so 6E is the ROM we want to look for. Actually, I think now that I think about it, I think he mentioned that in his email. So 6E, open with Workshop. But we also have to change MAME to actually look here in this directory. So it's user Brian B, desktop, Pac-Man. We'll just put desktop. We don't need to. Okay. So now we got to go to MAME and do the write MAME.ini. We have to change the ROM path. Let's do that. So it's users Brian B desktop. Okay, so that should work, I believe. Now it's going to look for the Pac-Man ROM files on my desktop. And I'm going to rename, just to make sure it does work, is I'm going to rename them from Pac-Man to Pac-Man 2. All right. Oh, it's in use. I can't rename it. There. Now, when I launch MAME, it should not work. That's important. You always want to make sure your changes when you do something are actually in effect. And so often you will, because it already knew where my Pac-Man ROMs were, I want to change it. I had to make sure it breaks by making sure they're not there. Okay. So MAME 64 Pac-Man tells me they're not there. Okay, great. I'm going to rename this from Pac-Man 2 to Pac-Man 1, and it should be there. Good. Good, good, good. Okay, so so he was said at line in 6E, open with Hex Workshop 0x690. If you don't have Hex Workshop, just get it. Pay the $50 or $90 for it. It's great. Okay, and that looks like it's probably correct. I always, when I use a Hex Workshop, I always make sure the columns are 0 through F, because it's just less confusing. It's easier to read things. Okay, now, yeah. So, and now I want to bring back the main debugger. Oops, I don't want that. I don't want list XML. I want to actually debug. And let's put that breakpoint back. BP 0x690. Breakpoint set. Start the game. We'll break at 690 and we'll see the instruction. Okay. Oops. Okay. So here we are. We have XOR A, load A to there. That's going to load A. So whatever we do to A is going to be nullified by the next instruction. So we actually can do a couple things. We can actually remove this instruction. We can, if we need to, we can add some bytes from this instruction. There are all kinds of stuff we can do here. And that was one of the questions. The guy was like, how do I think he wanted to, the instruction he wanted was a different size. And you have to, when editing a binary file, let's say, this instruction is 3 bytes as it is. It's 32, 13, 3, 4E. If we put an instruction that had only 2 bytes, that wouldn't work. Now you can do something. You can put an instruction that has 2 bytes in there and then add a no-op, something like a 1 byte no-op, but you cannot alter the size of the file. So if you remove an instruction, you change an instruction and it decreases in size by 1 or 2 bytes or whatever, you need to fill in the difference somehow. If you don't have enough data to, let's say you want to add, you only have 3 bytes here, but you want to add 10 bytes of instructions, you have to jump somewhere else. You have to find some code that is called a code cave, basically. Somewhere that's empty that you can, without damaging the rest of the code, empty out, put your own code in, jump there, put the code that because the jump instruction is going to actually alter some code. You need to move those instructions into the cave, if you will, and then your own instructions, and then jump back. So let's see how do we do this. Basically, we want to load into this address a value. All right, so we got to get out. I don't remember Z80 assembly offhand, so because I don't program it in much ever. I mean, I do when I'm hacking games, but then I just look up the syntax. So I'm going to go and find the Z80 site that has Z80 instructions and see what we can do. Okay, so looking at the Z80 instructions, it doesn't look like. It looks like you have to write a value directly into memory. You have to have it in the register A first, or there's other registers you can use, but without knowing the context of what's going on, the only thing we can really change is A. So there's no instructions that I can, I can't just with 4 bytes of code make this fit. However, with 5 bytes of instruction, that's not what I want. With 5 bytes of instructions, if we pull up MAME, we can see the instruction above this one, which is going to most likely be the one run, unless there's a jump that just takes you directly to here. The instruction above this is a no-op, which we can steal that byte and use it. And if I have an extra byte, then I can change it from XOR A to load 7 into the register A, which is this right here. Load A7, then load the memory address, the value of A, and that gives me exactly 5 bytes. So that's what we're going to do. We're going to now go ahead and edit this in Hex Workshop and see if that works. So, Hex Workshop, where are you? Okay, we got it. With 6E, open with struct to Pac-Man. No, we're opening this with Hex Workshop. So, and there we go. There's our address, and it was actually, I think the 690 was the instruction, and there was 1 byte before. So 690 80 And let's just go to 8C. That's just a few bytes forward. And here we go. We had the 0. There's our no op. That was our byte before, and then this is 6. Oops, nope. Sorry. 68C. The byte before that. So here's our 690. Where was 6? No. What am I doing? Here's 690. Right? The instruction before that was XOR A, and then the instruction before that was a no op. So we're just going to change this to, we're going to leave this instruction as is, 32, 13, 3A. Yep. We're going to change that these two to 3E07. Oops. Now I have to make sure that I'm in overwrite mode in Hex Workshop, and that I don't just push it. So anyway, what was it? 3E 3E07. Good. Now we're going to save that, and that should load 7 into there. Let's see what happens. Okay. Let's see what happens. Where is MAME debugger? Here it is. Now we should get, yep, we're expecting that. What the heck? Get this out of here. All right. We were expecting this because we edited the ROM. So it, you know, we should have expected that it's going to say, hey, something's wrong with the ROM. Let's put our breakpoint back at BP 0x690. You know what? Let's not do 690. Let's go 2 instructions back. So that would be FE8. Okay. And let's go. I can see if this works. And that is not working. That is not working. I wonder why. Okay. Why is that not working? Oh no. Oh no indeed. Oh. No, that's not right. Why isn't that working? That's odd. Let's set it back the way it was. It was AF. I think it was AF. Oh, you know what? We can figure out what it is. We can just add an XOR. Recompile that. And yeah, it was AF. So let's put that back the way it was. Open with Hex Workshop. And 0x690. 3E07. Okay. Here's 0AF. Alright, should be back to normal. Let's try that again. BP, oops. BP set 0x690. Go. Okay, so somehow, now that doesn't make any sense, honestly. That doesn't make any sense at all. Okay. I want to just edit that again, because that actually does not make sense to me why that happened. So AF. E07. Yeah, BP set 0x690 and okay, that's not working. Why isn't that working? I don't know. I see we're getting a halt. So to figure out why this is not working, we would have to more than likely pull up GHIDRA and see how, if anything's hitting that code. So we'll put it back the way it was. Zero AF. Oops. BP set, oops. BP set 0x690. Okay. So, all right. So it looks like we're not going to be able to directly edit that code. We will have to probably find a code cave and do the code cave jump, which we will do probably in the next episode. So we have to. I may actually do a little research. Mess around. I don't want to spend your whole time here, hours, troubleshooting this online with you or in the video, because I'm just wasting your time. If I figure out that I did something stupid in the video, I will, next video I'll say, oh, this is what I did, and then maybe we'll show you how to do the code cave anyway, and then we have to see if that actually fixes the problem, which I think we discussed earlier that it actually does not seem like it's going to fix the problem. I don't believe. And then we'll have to figure out how to fix the problem, which means we might need to do some MAME debugger. We might need to do some GHIDRA. Who knows? This is a kind of on-the-fly learning experience for. I'm seeing what's going on as you are seeing what's going on. So, hope you enjoyed it, and join me for the next one. Interestingly enough, just a few minutes after I finished recording that video, and I was like, hey, I wonder why it's writing twice to that memory address. And then I realized, I'm just walking through my kitchen like, oh yeah, of course it is. But we'll explain why. This video is way too long already, so we're gonna explain why. And I think in my next video I will have to use GHIDRA. I think that will be a good tie-in with everything. So I'll see you next time.